Today, you will be learning to work with binary numbers. Binary is a number system that is made up of only two digits, zeros and ones. Binary is sometimes called base 2 because it only has two digits. In contrast, our regular number system has 10 different digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This regular number system is called base 10. These 10 different digits can be strung together in any order to make any number. Computers process information and communicate using binary or base 2. You are going to learn to convert base 10 or regular numbers to base 2 or binary numbers. You will also learn to go the other way to convert from base 2 to base 10. Each of you should have gotten a page that looks like this along with the assignment activity for today. You will notice that there are several blank boxes on the page along with several flaps that have been cut at the bottom. Do not tear those flaps off. You will need them later. On the first empty row, you will need to write the expanded value of each block that was above it. For example, if we look at the first block on the left, you will notice that it is 2 to the 9th power. 2 to the 9th power is 512. You will notice that I have entered it onto my sheet here. Now, continue on down from 2 to the 9th. Resume with 2 to the 8th power, which is 256. 2 to the 7th power, which is 128. 2 to the 6th power, which is 64. 2 to the 5th power, which is 32. 2 to the 4th power, which is 16. 2 to the 3rd power, which is 8. 2 to the 2nd power, which is 4. 2 to the 1st power, which is 2. And 2 to the 0 power, which is 1. Your sheet should look like this when this row is done. Now, on the row below, enter the number 1 in each block. Your sheet should look like this when this row is done. Now, take each of the flaps and fold them up so they cover the number 1 in each column. On the back of each flap, as they are covering the number 1, write the number 0. Your sheet should look like this when this row is done. Now it is time to use the tool that you just created. Flip all of the zeros up except in the 5th column from the right. This is the column that matches to the regular or base 10 number 16. If you read the bottom row of your chart, you should have 0, 0, 0, 0, 0, 1, 0, 0, 0, 0. This is a binary number. This is the binary or base 2 number for the regular or base 10 number 16. Now, how do you think we would create the binary number 20? What if we flipped the 1 for the 16, which was 2 to the 4th power, and the 4, which was for 2 to the 2nd power? What is 16 plus 4? 20. This is how this calculation would look. Now, let's try a harder one. How would we create the number 508 in binary? The number 508 would be created by flipping the 1 for the 256, the 128, the 64, the 32, the 16, the 8, and the 4. All of those numbers added together equals 508. Now, let's see how to go from base 2 to base 10. We'll still be using the binary conversion chart that you've created. Now, let's say that we wanted to convert the binary number 1011001101 to a base 10 number. We would start by flipping the tabs on our chart to show that binary number. Let's start on the left side. Our 2 to the 9th power column should be a 1. 2 to the 8th power is a 0. 2 to the 7th power is a 1. 2 to the 6th power is also a 1. 2 to the 5th and 2 to the 4th are both zeros. 2 to the 3rd and 2 to the 2nd are both 1s. 2 to the 1st power is a 0, and 2 to the 0 power is a 1. This is how your chart should look. Now, look at the base 10 number that goes with each number 1. In this case, that should be 512, 128, 64, 8, 4, and 1. Now, add all those numbers together. What do you get? If you got 717, you are correct. So the base 2 number 1011001101 represented the regular or base 10 number 717. Now it's time for you to work on the lab activity that has been assigned for today. It has already been passed out. By the end of class, make sure that you have answered all of the questions on the activity. Put your name on the top of the activity and your binary conversion chart and turn both of them in for a grade. Half of your grade will be based on the lab activity, and the other half will be based on a completed binary conversion chart.